Hey, we're back now. I think I raised the volume on the Go XLR. I think we're good right there. Good stuff. Good to see you here, Jesse. Thank you so much right there. Got that nice, perfect 670,000. I've got a little crazy on the points. Basically, I wanted to make sure if people show up to class, they should be getting those points. It's kind of really nice at the end. It's like, hey, this material's getting a little more difficult. So, but hey, if you're here in class, you're going to get those points, right? Show up to class. We usually turn off the points after the last class, but you got to make that effort. So everyone, it's about an equal opportunity right there. Little crazy. I'm so close. Let's, you know what we might do, Jesse? Let's do this. Let's put, Jesse, I want you to name the level. We could alter the name to a student's name. We're gonna put that. Hey, Andy, good to see you here. We can take some questions. Jesse, what's gonna be the name of the level for the top level? What is gonna be the name of the level? We'll put it to 650,000. What is gonna be it? And then we'll actually, you did it level or something like that. Like, if people have the 0.29995, I'm just, I'm not gonna let that decide. But we'll go ahead. We'll do it. We'll assign. So you're going to be like the only one at this level. Other people might make it there. But of course, if someone has like thousands of, show up to class. Oh my, Jesse, that's such a, wow. Okay. You'll have to see when you update to this. Okay. Okay. Alright. Oh, wait. I have 0. Whoops. Let me re-edit this. Please don't mute-bot. Give everyone that. Okay. Now someone, if they had 0 points, it had the minimum requirement for the level for 0. Okay, Jesse, at some point you will update to this. mute-bot can take a moment or two to update. But it is officially there, and we can put a lot of levels between it. But at some point, mute-bot will update it. Oh, he already updated it. Hashtag show up to class level. 1.3 points. You did it. mute-bot's already updated. I got it. I know, right? And then you actually get points for watching. So I'm always trying to find out the right way to do this. So those 10 points you got right there, Jesse, you get points for literally just being in the chat and being active. Maybe I should increase that a little bit, because I think a lot of people don't even realize there's points just for like those 10 points you got. I know, right, Jesse? Do you feel like you understand statistics? If you want, how has it helped you? I hope, the goal is that this class helps you understand statistics. Good to see you, Izzy. I do. That's what we want. Yeah, I want people to like think about how this applies to their major, how this can help them in their career, how it's just kind of an understanding of the world. Oh, thank you so much. What's the goal? It's like we want you to understand statistics. And look, thank you, Scotty, right there. Appreciate that. That's good stuff right there. Well, let's check out some Ma Pearson, right? You want to do some 2 sample T's or some chi-squared? What should we do? And then the big thing is knowing which one to do and when. Why do we do the chi-squared? We have 2 categorical variables. We want to look to see if the 2 variables are independent of each other. Why do we do the 2 sample T? We have 2 groups, and we want to compare the means of the groups. The T is a test on the means. Disappear, reappear. I did not know we get 10 points for being in the... Yeah, you see, I need to make these things more clear. Like maybe I need to make just a video explaining how mute-bot works. And then some people don't realize that you have to talk to some degree to get the points, because all people email me at the end of the semester and say, wait a minute, I went to every class. I'm like, but did you chat? And they're like, we have to chat. And that's why mute-bot has a message now that he says every so often, like, I have a short memory. Make sure to chat every, I think, 15 minutes. So if you don't chat every once in a while, mute-bot forgets you. He thinks you're inactive. And then there's other things we could do with points. Like you can play games. There's actually like duels. Or maybe I'll turn it on for a moment, then we'll get serious here. Where is it? Games. We used to do the counter stuff. Watch this. We used to do stuff like this. We have so many things that I've done in the past. I think that's on right now. Brian has made. I think that's how you use this. People would have fun with this. I used to turn the. So people would have fun with this when I made errors. We haven't used this in a while. but that's the command to do errors right there. So you can like control how many errors I've made. There's queues. There's song requests. I don't know if song requests would work. Also, copyright claims. That's how to get. You can do raffles. I have no idea how to do the raffle command with Mubot. Extra quotes. Oh, those are jokes. We have jokes. We have jokes, and we have quotes. Things people have said in the class that are oftentimes really funny. There's the timers, commands. Where's the games? Events, scripts. He even says thank you to subscribers. Mod tools. Yeah. Betting. Oh, so you can bet points. So this was complicated though, and it always took me a long time to do. What was the last quote made? People are born and they're 0 years old, not 1 year old. Zero index proved with logic and facts. Oh, so that's about when we code. I'll mention. I can't remember who said that. Do you know about index 0? So what index 0 means, if something is an index of 0, it's like when so imagine this. There's 3 people in my family, or children. So there's Emily, Brian, Darren. Or let's do it in order in which we were born. Darren, Brian, middle child, Brian, Emily. So does that make sense? So the reason I think about like index 1 means Darren, if we call these the kids, Darren is the first child. Does that make sense? Like Darren is the first child. But if you were coding in Python, you would reference Darren by saying he's at index, and that just means position 0. So that's the idea of like an index and a vector. Does that make sense? Like if this was Python, which is indexes at 0, then you would say child 0, like child in position 0. The position is just like an index. But I think I prefer index 1, but someone was making arguments of index of 0, like your age starts out at 0 and then you're 1. So they were like, oh, there we go, proven with logic and facts. Because some people prefer the index of 0 and some people prefer an index of 1. So that's when you start indexing things. You say this is the first thing, this is the second thing. Indexing of 0 would mean this is the 0th thing, 0 position. This is in position 0, position 1, position 2. So it almost offsets everything. I'm not a big fan of index of 0, but some programming languages use that. So this will say that there is nothing in that position. Yeah. So that's just a student was saying that as we were talking about coding. So that was a fun quote right there. Quote 181. Which one's that? Was that the P times Q over N square root? Is it? Oh, you have to do a space between it. So it'll be quote and then 181 like that. Is that P times Q over N square root? Oh, yeah, I remember this from Geology 1. Hey, yeah. I see that's nice. I like nice things like that. Here's betting. I can do betting where we say betting on what is better. Better. Pizza or tacos. So he should put the betting. So betting started. What is better? Minimum bet 1. You can enter the amount. There's like 300 plus quotes. I can go over to it. We got like tons and tons of quotes. What is better, pizza or tacos? So the betting, that's why I used to do that, but now I've gone over to doing the YouTube polls. You can do your points here, but the way you have to do this, you see, Mubot says how to do it, but it usually I have to explain it to multiple people, and then someone comes in who hasn't been in class in a while. So you have to go bet 0, 10 points. And now if you look, Mubot's going to register my bet right there on pizza. I always feel bad for yeah. See those things. It's like things like that people have said that crack me up. Like we're talking about Alabama, and like we were talking about them losing, and someone was like, "Oh, I always feel bad for Alabama." Andy's betting right there. I'll have to. Okay, well, don't bet tacos because I don't want to. I might have to. We'll see. So the way this works then is you see Andy has their vote in here, and so then I can pick the winner. I think I go here, and I have to stop the voting, and then Jesse also bet, and then we go here pick winner. And you select, are you selecting where everyone points? Who bet on this option? Yes. So this might be interesting because, see, then everyone has to know how to do it. That's the problem. So you see, there's your points awarded. Oh, Mubot. Yeah, it's like people say stuff like that and it cracks me up. So it's it's kind of neat because then you can use your points to bet on stuff, So if you look at your points now, Jesse, you should have an additional 1 on there. So if you do if you want, your exclamation mark points, and it'll show you your points. But I'm always looking for ways. So if people know about streaming and stuff, you'll see you should have. Oh, but do you not? Mubot might not have awarded it. Bet all. Maybe it didn't award you the points because you bet 1 point. So logically, you should have the additional point on there. Let me go over here and look in Mubot's memory. I mean, he updates it as he goes. So I'm going to go over here to currency, and I'm going to go and look, and I'm going to go double check. Well, you see, that's a reason to not do it now, as The Rock would say. It doesn't matter. Well, apparently he doesn't update the points. He's set up for like Twitch and other stuff, so I didn't even know that feature was broken apparently for YouTube, which sucks. Excuse my language. But oh no, Jesse, I know what it is. Okay, wait. Here, wait. I figured out the issue. Okay, Jesse, you ready? Bet 1 on pizza again. Do it again. Bet 1. Just only bet 1 on pizza again. I'll be like Andy and bet 100. Now, I think I figured out he does do it. And so once you do the bet right here, or maybe I think I had to reset it. 2 seconds. We're going to have to redo it again. Stop, reset, start. Okay, do it again now. But it might be that I made you wager points and then you... Okay, try it again now, because I think that bet was already... Oh, it's got a time remaining. Interesting. Oh, I didn't use the timer. Oh, then will it, like... There's ways to do this. Brian's thinking about... So try to do the bet again, and it'll register on the screen here. It should register your bet then. And then... I think this... So what it was is I had the payout to 10%, which... Why would you give a 10% payout? If someone's betting points, you're like, oh, bet your points, and if you're wrong, you only get 10% of them. You only get 10%. I mean, if you're right, you get 10% more. So I think with the 100% payout, then you will get your point. You will get a point. So you'll have to do the bet again, though. Like, you'll have to... Because the bet's not registered right now. There's no bet in here. And now I'll just select you as the winner. So it's like, it's not that bad. Like, oh, where'd Jesse go? Oh, wait. Do the bet again, though. Try doing the bet again, register it, and then check your points afterwards. Like, bet the 1 point. I'll stop the polling. Then I'll pick the winner, and you'll get your point, probably. There we go. So now you bet it. I stop. I pick winner. And so it's not that bad. So yeah, you see now Mubot said you got 2 points. So Mubot's telling you the additional of it. So now you should have that. There you go. So it did work. It's just that the payout was 10%. So because it was 1 point, it didn't even round up to an additional point. So it does work. And it's not that hard to realize what you're doing, right, Jesse? Like, that's actually kind of coding. Like, the function that's a function right there. Like, you are doing the bet function, choosing option 0 and betting a certain amount of points. So I bet 2 points. No, you bet 1 point and you got 1 point. Does that make sense? So now we did it multiple times, but for how much you bet, you will get that much back if you win. So you bet a point, and then because you were right, you got an additional point. So you basically doubled your point. So imagine you had like $1 and you bet that dollar and I hand you back 2. So you were at like 1 less point because I handed you back $2. You said, here's $1 that I'm betting. And I said, oh, here's $2 back. You bet. Oh, no, the other one didn't go through. The other bets were not. So what you have to do, so if I start this again, like do the bet again and watch, it won't register, which I always forget these things too. So now try betting again, but watch, it won't do it. But what's interesting, and this is where I'm learning about this too. So you see now it didn't go up to 2. But if I hit stop here again and I go to pick winner, it might have just given you another point. Hey, Philip, good to see you here. Ask questions if you got it. So I think, Jesse, I just gave you another point. So if you reopen the point, yeah, don't worry. Well, you helped me learn a little bit about how to use this. We're talking about how to like, so yep, there you go. You got another, or you got it twice. Oh, because you put a point in the system, And then now I gave you 2 points back, but you still just had that initial point you gave me in the system. So now you got 2 points because you didn't actually have to put another point in the system to put your bet in. So, I mean, that'd be good if people are already doing their bets early, but then I can reset it right here. But yeah, so figuring out how to use this. There's mini games. So how close am I? You're getting kind of close. You'll probably get there. The level is, so I can show you the level now. If you want to see all the levels. So here's every single level. You ready? Oh, wait, you about to come back. Here's all the levels, and we'll respace them out next semester. Oops. So here's all the levels right here. We got Legendary tier, Hall of Fame tier, Hero of Eternity tier, Hero of Eternity, new Legend of Zelda coming out soon. All the tiers right there, and then you go down here. Here's the newest, highest level. We'll put some levels between this. The show up to class level, 1.3 points. So you're getting pretty close, Philip. We'll probably get there like next class or so. You might be one of the highest in your class, so we'll try to get you there. Cassidy's level, Cassidy's awesome level, Jason's Jamboree. We'll put some more levels between here if people keep nominating people, which I always like. 320 needs to nominate some people too. But yeah, there's also the mini games functionality, which I don't have these turned on, but you can actually like duel people. Yeah, nice job, Phil. We can do some work here. So you can actually do like heists and duels. So boss battle. Okay, you ready? What's boss battle do? I've thought these would be distracting if we had these on. Like my thoughts on these. I think my mic might be a little high. I'm turning it down just a little bit here. He's trying to get a group of together to fight the boss. Will you join them? Type boss to join. Do you want to try that right there? So type boss to join if you want. We're just seeing things. I don't know. So it costs you 50 points. Don't worry, it's a little bit. What is player stats? What? Starting mission. But I don't think there's any bosses. Stat enemy. Stat bad guy. Calculate chances. Survival rate 0. Oh my gosh. Health 2. Sure. Quick question. Is there a video on chapter 17? Yeah, which one are you working on, Andy? We can get work on it here. This is interesting. I've never this is all new to me on doing these things with Mubot, which I think these could end up being distracting for class. I'm gonna go thrifting. Yeah, awesome, Philip. Enjoy. I don't know how to start the boss battle right here. And Andy, which ones are you working on right there? I'm gonna turn off the boss battle here in a second. But there's so many neat little things you can do. And I have no idea how to start the boss battle now. Viewer stats, regular stats, moderator stats, sponsor stats. Oh, that's neat. Well, I mean, yeah. I have no idea how to start it. Cooldown, start delay 2 minutes, cost 50. Okay. Well, we'll see if it starts up. We'll see what it does. Which ones are you working on, Andy? We'll get working on that here soon. The combatants have entered the arena. Will they able to defeat the stats bad guy? They plan as you erupt the weapon. Suddenly, a sandstorm emerges. The dust finally settles, and only the fallen people emerge. Did you see? Yeah, he saw the new level there. Well, that's kind of neat. That'd be... It's just like a random... It's just randomness. 3 was one of them? Yeah, let's go do 3. Let's go do some work. Well, I'm going to turn off boss battle here. That's kind of neat. There's a lot of features I haven't checked out with Mubot. And so even I'm like seeing what's new, what's possible. That's what we like to do. It's like check out these things and say, hey, what's this thing here do? What does this do? Thing. We'll get some sleep. Let's go over here to Ma Pearson. go in and do number 3. Loading up the homework. Okay. Yeah, which one on the quiz, Isabella? Let us know which one on the quiz, and we'll start doing it. I'm gonna move Mubot over the screen if he's not there yet. Mubot goes over there, and here we go. Let me mark the thing. Okay, let's do it. Suppose an experiment was done to gather the data on the number of unpopped popcorn kernels from a microwave popcorn. Half of the students in your class put the bag in the freezer overnight, and popped it the next day. The other half took the bag and left it on their kitchen counter overnight and popped it the next day. Each group counted the number of unpopped popcorn kernels. The class constructed a 95% confidence interval, and we see the following values. Now, the important thing is to know, what does this interval mean? And that's what we're understanding right here. What does this interval mean to us? So can you 2 questions on the quiz? Yeah. Mm-hmm. Is that on the chapter 17? You bet. So let's take a look at the following data. This is the clarity of a diamond explaining the price of a diamond. Good question, Isabella, too, right there. And so with this right here, why is this a 2-sample T? Look at clarity up there at the top, or cut. Let's go to cut, rather. Why is this a 2-sample T? Look at cut. And what about price? So why is this a 2-sample T? Like, when do we use the 2-sample T? So understanding when we use the 2-sample T is the first thing to know right here. Why is cut? And look at cut up there at the top. There's the variable cut. You can see it's red. And then price, which you can see price over there in dollars. Why is it a 2-sample T? So the big thing, and these are the important notes you want to have written down, is the 2-sample T is when you have 2 groups, 2 samples, 2 groups, ideal and premium diamonds, categorical variable. So the X is categorical, and then the Y is quantitative. T, mean, Mr. T, if you're doing drugs. So we have here the 2-sample T test. Now, we get right here side-by-side sort of dot plots. We could turn them into box plots and do side-by-side box plots right here. So there's our side-by-side box plots, which we can do for the project also. But then in addition, we can go here and do the t-test. Now, JUMP just calls it a t-test. It is a 2-sample t-test, which is a type of t-test. And when you get the results, you see the following. You see it is statistically significant for both, or the does not equals and the greater than test. But what does this all mean? And so we really want to narrow it down and look at the output and get an understanding. So here we are. Now, if you notice, the difference is positive. Hey, Sloan, good to see you here. What does the positive difference indicate to you? What does the positive difference indicate to you? And here's a good way of thinking about it. What does the positive difference indicate to you? That the blank blank for blank was blanker than the blank blank for blank. Now, we are comparing these values. The mean price for premium minus the mean price for ideal. So what does a positive difference indicate to you? What does that, so we have to think, what does that difference mean? The positive difference would indicate that on average, premium diamonds cost about $881 more than ideal diamonds. This is because the difference is positive and we're doing premium minus ideal. If the difference was negative, then that would indicate that the second mean is on average higher because it would be that ideal had a higher price, so premium minus ideal would equate to a negative number. Now, think about the interval. The interval is just created around the estimate. The estimate is the center of the interval, and then there's a plus or minus. So if the estimate's about 881, then if we go kind of plus 700 and minus 700, now this is not exact, we go up to these values kind of here. Now that's not exact, but kind of 881 plus a certain amount, 881 minus a certain amount. And what do you notice about both these values? So feel free to answer in the chat for 1,000 points. What do you notice about both of these values to estimate the real difference? Both of those values are what? And this is where we're going back to what the question's asking us about. Both of these values are what right here? Very clearly, both of those values are what? Chapter 17? Mm-hmm. Is that on the quiz or the homework, Isabel, right there? It's a quiz? Mm-hmm. What do you notice about both those values? Both of these values are what? So the confidence interval says, I am 95% confident the true difference between the mean price of a premium diamond minus the mean price of an ideal diamond is contained in the interval 212.82 to 1550.33, and this is evidence that which diamond costs more. Both of those values are positive, and since both those values are positive, that's evidence that the first mean is higher. And also, we would reject that there is no difference for we could do the does not equals test there. So it coincides with the low p-value. So how does this relate to our question right here? Well, the question's doing the same sort of thing and giving us an interval right here. Both of these values in the interval are what? Both of those values in the interval are what? So we're trying to estimate the true difference between the average amount left unpopped in a freezer bag and the average amount, great job, Sloan, right there, and the average amount left unpopped in the counter bag. So which mean was higher? Which sample mean was higher, the first or the second? So when you look at this interval right here, which sample mean was higher? Because this, remember, the difference we estimate to be negative, so that it would be evidence which mean was higher. So since we're estimating that the difference here is probably negative between the means, the second one. Good, and think about this. Good answer, Sloan, right there. If you do like 20 minus 80, what does that solve to? 20 minus 80 solves to what? Negative 60, right? So that would mean that the second mean is higher. But these numbers are not the numbers that go right here. Like that number and that number are not the numbers. This would find the what of the interval. Like if we took, and I'll find what the answer would be. So the answer needs to be basically 175 or 75. If we had something like what is that find of the interval? That would find the what of the interval. And hint, that's when we do y bar 1 minus y bar 2. So what would that find of the interval? That finds the what of the interval. The first thing in a confidence interval is the what of the interval. So the very first thing, it is the difference between the means, correct? And that is the what, like, so what, here's another confidence interval. The very first thing, great job, Jesse, right there, is the what. Like, what is the first thing? What is the very first thing in the confidence interval? The margin, correct. These are all margins of errors. So what's the first thing called, though? a few names we can call it. The first things are called the what? What is the first thing called? Everything after the plus or minus is the margin of error. The T or the Z give the confidence level. The standard error is a measure of variation. And the first thing is the what of the interval? Well, it comes from a sample. And the sample gives the what for the interval. Our best guess, or known as the what for what we think the truth is. The sample is our best guess of the truth, estimate or center of the interval. Great job, Sloan, right there, and good practice. So that's the estimate or the center of the interval. And so we would get that by averaging the two numbers in the interval. Does that make sense? Like if you take these two numbers right here and average them, that will get you the center of the interval. So notice 50 and negative 124, that would average, or that when you take that difference, it's going to be negative that. And that is the center of these numbers right here. And then what would the margin of error of this interval be? Which there's a lot of ways to find margin of error. So just one last question right here. Correct. Yep. The general format we use. And then, so what would the margin of error of that interval be? I think I know it. Double check my work. What would the margin of error of that interval be right there? So we can write, we can check our work. What would the margin of error be? And then we'll do, Isabel had a question too. So what is the margin of error? The margin of error is just what the length of the interval. So there's a lot of ways to find it right now. When you think about a margin of error, if I were to tell you a steak dinner costs between $50 to $70, I think a lot of people know how to find the margin of error. So what's half the length? It's 40 what? 42 point what? So you're like, okay, got half the length. Oh. The more you do these, the more you practice these, the more you get to like, oh, the margin of error is half the length of the interval. That interval has a length of 20, then the margin of error is 10. It can be described as 60 plus or minus 10 right there. But how about this interval right there? That interval has a margin of error of what? So what we do, you can do it as positive numbers if you like. There you go. Half the length of the interval. Doesn't matter if it's plus or minus, because we are just going to go the positive or negative, and then you can check your work by seeing if it adds to those values. Now, I just came up with theoretical fake values right there. It's kind of weird that there's a half-popped, unpopped popcorn kernel. My Pearson doesn't check their work that much. But since the interval is negative right here, both numbers are negative, so the second mean is larger. That's because the negative interval would indicate a higher second mean. Good job. And so Isabella was asking about, sorry for the chapter 17, do consumers spend more? Let's go find that question. I think it's the Target or Walmart, right? Do consumers spend more? Here we go. Do consumers spend more? Let's go shopping. Okay, do consumers spend more? Here we are. You're welcome, Andy. Is that your question? And let's go right here. Stat 201, chapter 17 quiz. Do consumers spend more? Okay. So do consumers spend more on a trip to Target or Walmart? My Pearson's sponsored by Target and Walmart, apparently. So when we write this out, I know, well, you can swing by anytime, Sloan. And when we write this out right here, we have to think about what does this say in words. So when you write out your null hypothesis, you want to be able to read this. So remember, when you're reading it, we'll go to the right ones. Let's hear it here. The means are equal. Good. So this is going to be the right one, but let's talk about what it says and why we picked this. So the understanding here is when you read a null hypothesis, let's go to what it means. I know, well, swing by anytime, you guys, gals. So here we are. The null states, that just means you currently believe. Like I currently believe that if I were to subtract the average price of Target sales minus the average price of Walmart sales, the difference would be, or would equal 0. There would be no difference. That's the same thing, and I prefer to write it sometimes, that the null says, that's the null says, my initial belief is that the average price for a Target is equal to the average price of a Walmart sale. The alternative states, that's just what I'm writing right there. That's how to read it. The alternative states, my thing I'm looking for evidence for is that the prices on average at Target are not equal to the prices on average at Walmart. So remember, these are average prices. It's not about one price. It's on average. Has Sloan seen it yet? You can show it off, Jesse, with the points. So the reason we're picking the does not equals alternative is because the researcher's question illustrates the alternative sign. So they want to see if the two means are equal. So the null always has the equal sign. Whenever we do the null, it always has an equal sign. The alternatives sign will be based on the question. And so we will pick between these, but since we're testing equals, the alternative will be not equals. So that's what we'll have right there. Now, this is also super important because later on, it'll be how we shade the question. It jumps right into it here, finding the t statistic. But what are the 4 conditions? Can you list out the 4 conditions that we would need to test for the t? So 1,000 points right here. If you can tell me all 4 conditions for the 2 sample t. The 2 sample t, remember how to do these? We always do condition 1, condition 2, same things. Then we pause and ask what kind of data are we working with? And then the 2 sample t has a 4th condition. So it doesn't ask you the conditions here, but I want you to remember the 4 conditions. Remember how we do it. Condition 1, condition 2, and then you pause. Is it categorical? Is it quantitative? Or chi-squared? And as we just did chapter 19. And then last but not least, there's a 4th condition for the 2 sample t. So what do we got on the 4 conditions? Hey, Patrick, good to see you here. What do we got on the 4 conditions for the 2 sample t? If you're at home right now, see if you can remember them. This is a good part to remember right here. Remember, it's the t, which is quantitative. There's some hints. So condition 1, I'll start saying a few of them, is random. That means we've randomly selected individuals who went to Target and Walmart. You can also assume independence, but randomization covers it right there. Condition 2 is we've sampled less than 10% of all the Target and Walmart customers. Now that'll be the same for each thing we do for conditions on test 3. Now you pause and you ask yourself, is this quantitative or categorical? Now T, the 2 sample T, is going to be a quantitative test because we're testing the means. There are 2 groups right here. I know it's 2 groups, but the variable of interest is how much are they spending. So that's where we're analyzing the distribution of spending between 2 groups. So the question of interest, the Y, is how much are they spending. Show up to class level right there. We love it. And so with this, the 3rd condition is nearly normal, which means the distribution of sales at Target need to be nearly normal. The distribution of sales at Walmart need to be nearly normal. Lots of ways to check that with like histograms, normality plots, goodness of fit test, and the large enough n condition. Those are ways to check the 3rd nearly normal condition. Now, the 4th condition is independent groups, which state that the people who shop at Target do not directly influence the people who shop at Walmart and vice versa. So we probably have that. That's not like Target's running a sale that is going to drastically impact Walmart. It's independent enough, we would say. You can always come up like, well, maybe Target's kind of taking up some of Walmart's sales. It's probably, you got Target and Walmart in a city. I can't remember the 4th. Yep. So independent groups is the 4th. And remember, it's just the 2 sample t-test, and the 2 groups need to be independent. So when you do the 2 sample t, there's 2 groups, and the 2 groups need to be independent. So I'm thinking you're saying that right there. That's the practice we need because a lot of times people forget there's a 4th condition for the 2 sample t-test. Chi-squared also has 4. I'll talk about that here probably soon. So the test statistic t, it really is going to boil down to just doing the notation right here. We also get the degrees of freedom, so you have to know your notation.
Notation, brother.
Thank you, Leo. Here's all the notation. If you want, TD, let me talk about that here in a second. I might go another rant on it, or I can send you the deep dive we've did into it, because what it is you've actually overcalculated the standard error. If you sample too much of the population, your confidence intervals come out wrong. It's very odd and interesting, but the calculations are actually off when you have too large of a sample. And I can send you the video on that, or I could kind of talk through it here again, because it's counterintuitive. but it's that your calculations are wrong mathematically. You actually have to do a correction, and I might even go. I'll pull up the video here right after this. Yeah, it's insane. Yeah, please stay because I want to show you it. It's really it's counterintuitive. Then when you see it, you're like, oh, that makes sense. Because I figured out an example and it made sense to me. I was like, that makes sense now. The two sample t is t with degrees of freedom, which they gave us right here. And then that is equal to, we need to do y bar 1 minus y bar 2 over square root s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. And we put in the means of 45 and 53. That's the difference of $8. We square the standard deviations respectively, and we put the correct sample sizes below. And let's solve it. So standard error is a metric of variation. We are just doing a difference standardized. That's how most tests are done in statistics, is we're taking a difference and turning it into a standardized unit. So we'll get a difference of -8. 21 squared divided by 82. There's that. 19 squared over 81 plus the other one, basically 3.2-ish, 3.13, -8 over 3.13. Now, every time we do this, I've been really good at this lately. When we get the t here, which is the standardized difference, we like to take a guess at the p-value. Now, Sloan, Sloan, thank you so much right there. Everyone, 1,000 points. So, Sloan, you might be able to guess this, Sloan. But so where are we going to go? And I want you to take a guess at the p-value. I will throw 5,000 points if you get the p-value right with a guess. Sloan might go and get the real answer, though. I wouldn't blame him. I'll probably give him the 5,000 points still if he gets the real answer, either which way. It'd be more impressive if it's a guess. Now, remember how earlier we said we were doing the does not equals test? Well, that means we are going to not only graph the side of the curve where we land, so we're going to go to where that t is, and we're going to graph right here. It's a little technically further over. And then we're going to reflect it on the other side and do one just as extreme. And that is very specifically because we're doing the does not equals test. If we did the less than, we would shade to the left. If we did the greater than, we would shade to the right. So the sign of the alternative, you got this, Sloan, I trust you. So we are doing the does not equals alternative. Ooh, Sloan, I think you might have it. And you're talking as a percent, right? So give me that as a decimal instead. Because Sloan's talking as a percent, but as a decimal. Sloan, that is a really good guess. Like, that's really good. Sloan, you might... That is... If you guessed this, Sloan, which I'm thinking you did, I mean, I asked you guess it. Either you know how to use the apple or you know how to make really good guesses. Because that is probably going to be really close to it. I'd be shocked if you didn't get it right. So let's go ahead and put this into 2 decimals right here. Yeah. Well, wait a minute. It might be close enough. I think it's closer to... It's going to have more area in the tails. I think it's closer to this. You might be close enough, Sloan. I'm throwing you the 5,000 points either way. My guess is this, Sloan. We're going to go with Sloan's guess to start. And then we're going to show how to get the answer, so if you're wondering. But Sloan, using an alpha of 0.10, do you reject the null or fail to reject the null? So remember, when the p-value is low, you reject the null. When the p-value is high, you just let it fly. So the p-value is this. My p-value of 0.009 is less than my alpha of 0.10. I am going to what? Reject the null since it's less than alpha. I didn't click the 5,000. Reject the null since it's less than alpha. That means I have evidence for my alternative, i.e. sufficient evidence. So we reject the null. There is sufficient evidence. You might be close enough. I think it's closer to 0.013. Yeah, I think it's a little bit bigger. Yeah. Very good guess, Sloan. It's because I know some numbers. I was like, I think it's a tiny bit bigger, but your guess was very close to it. You could have said about 1% and it would have been basically right. Let's show how to get the actual answer right here. So you were super close to it. Great guess. Yeah, you were very close. I was like, I started to think it over again, and I was like your guess was really good, and then I was like, it's a little tiny bit bigger. And I can explain how I know that. We're going over here to the T-applet. So when you use the T-applet, a lot of people get stuck on this because you have to get the degrees of freedom. If it's not given to you, you will have to find it by the too complicated formula which the applet solves, but this one does give the degrees of freedom. Now remember, we are going to find the p-value using the t. So make sure you've clicked this button. The link is in the chat to the app. Find p-value using t. And from here, we enter in the degrees of freedom given to us. This one is very nice. And then we have to remember, are we doing the greater than, less than, does not equals, or making a confidence interval? We are doing the does not equals test, and that's where early on we decided that right here with the does not equals. The less than alternative would be below what we find. The greater than alternative would be above what we find. And this is generally used for making confidence intervals right here. So let's go to the outside, and we're going to take our z-score right here, drop that in, and then put the positive version. And then as we always point out, whenever there, like I said, basically 1%. Oh, see, Sloan, even I was off. I should have done, did I say 1, 2? I did one moment. But Sloan, you might have literally been at the so close that it just, you almost had it. And here's the thing, Sloan, what do we always say? And we always point out that if you can draw your own picture of this, so try to draw your own picture, and then take a look and see if the applet gave a picture that looks like yours. So you want to try to draw your own picture and then say, did I then draw this very similarly to what we have on the screen? And I think we did a pretty decent drawing. The tails are a little bit less area, but overall pretty decent drawing. And Sloan, I really think you were right so close that if we had just gone to 1%, no, we were, it only has a plus or minus of a thousandths. So you were very close though. That was really good guess. So I just barely got it. I was on the very edge of what was acceptable, but still really good guess. And the reason I know this is because this curve right now is a lot like the normal. This is just the extended part of this question. The reason I can usually guess these really well is I know a number, 2.5758. You say, what is 2.5758? 2.5758 is the p-value for a 99% confidence interval. So if I know 2.5758, then I would know that outside of 2.5758 is 1% of area. So when I thought about this, I was like, it is very close to 1%, but this is the T, and the T has a little bit more area. Now, I know we were at like 2.55, so I was like, but the T has a little more area in the tails. So I was like, it's going to be close to 1%. And I was like, maybe because it's still not got tons and tons of degrees of freedom, it's going to be a little bit bigger. Oh, did Ben have one? How do you do the chapter 10 question? Yeah, well, we can do that one. The homework is static. And here, I'm going to give a quick thing on the, really quick. So Didi, are you still here? Really quick, we'll talk about I'm going to show the deep dive video and link you to it. Because we learned a lot, and I would be interested in your thoughts on this. So let me go bring up that deep dive, then we'll do the next homework problem here. So the deep dive was done. Let's find that deep dive question. Thank you so much right there, Sloan. It's around the 24th. 25th. There it is. 10 condition. Okay, here we go. It was on a wacky Wednesday. Awesome. Well, I've got the link here. So I'll show a little bit of the math right here, and then I'll do the next question. So let me put this in the video so people can check it out. I'm just going to keep saying stat 201, 10% condition explained. So what it is, think about if you were like taking the results of an election and you had 20,000 of the 20,001 votes. So when you do it, and I think I worked all the math right here and showed that somebody would create a confidence interval that was 49% plus or minus 2.2 using the classical methods. But the issue is they're actually using the wrong formula because there's a correction for the amount you've sampled, which would decrease the standard error. So if you've already sampled 2,000 out of the 2001 population, then it's going to make this smaller because think you're doing 1 minus this, and then you're square rooting it. So that would actually make it a tiny bit bigger, but still, it's still a decimal. So you're going to multiply the standard error by a decimal by the amount of population you've sampled. And so this quantity actually gets to be very different when we sample more than 10%. So you can think about how this quantity right here, if you sample such as like over 200 right here out of the 2000, then you're going to get a value right here, which is a much smaller decimal. And then when you multiply it, it's going to drastically decrease the standard error. The standard error is a metric of uncertainty. And so your uncertainty is actually smaller when you've sampled more of the population. It's not that you can't sample more, it's that you would actually need to use this correction by saying how much have you sampled out of the total population. So it's actually a really, really neat sort of idea right here. And then we calculated the proper interval. So here's the proper interval. So here's the wrong interval. The wrong interval would be, there it is right there, 46.8 to 51.2. And then the right interval with the correction would be 48.95 to 49.05. So we can still do statistics. It's that you have to add on the correction because, so this quantity becomes kind of a big deal when you reach that 10%. So that's the math behind it. I thought I really wanted to understand it a lot better because everyone's always like, why can't we sample more than 10%? The answer is you can, but you should probably use the correction, which would lower the amount of uncertainty because you already know so much of the population. Oh, thank you so much. Hey, let's do the, drinking size. Yeah, we haven't done that one today, so let's do it. Drinking size question. I'll try to give a different spin on it. I'll try to do it a different way. What I try to do a lot of times is, Sloan, you rock. Let me throw you another 5,000 points here. I absolutely love that we've got so many videos to help people out, and the fact that people, so Sloan earning everyone 5,000 points right there. The chapter 19, let's do that next, Isabel. Thank you so much for waiting, Isabel, for that question. We'll do this version kind of quick-ish-ly, and then we'll do Isabella's question. Which one did you want, Isabella, again, on chapter 19? Points for everyone right there, thanks to Sloan. And we're going to do this question right here. And which one did you want, Isabella, on chapter 19? Okay, here we go with the drinking glass. Okay. Whoop. Awesome. So here we go. We'll give a new spin on this. Sloan's already got a version of the video in the chat. But let's mark this one right here. And Stat 201, chapter 17. Researchers investigated. Chapter 17 quiz. Okay. The one with the pregnancies full term? Yeah, we'll check that one out next. I think we'll be doing it. Here we go. And so with this, the question is, we're giving people two glasses right here. We're giving them a big glass and a small glass. It's kind of limits to what the glasses can hold. I got these like really like orange drink in there. Good stuff. So you're welcome anytime. And so with this, 30 people were given the small glass, 26 people were given the large glass. The average amount put in the small glass was 4.92 ounces. The average amount put in the large glass was 6.28 ounces. The variation is measured by the standard deviation, which is a metric of spread right there. Oh, thank you so much. That's really kind of you, Sloan, right there. I don't know. It's really nice people say nice things. I don't know. It was very kind. Thank you so much. That makes my day. And then the large glass had variation of 2.97 standard deviation, which is a metric of spread of the variation. When you think about variation, like the small glass, probably due to it being smaller, has less variation in the amount of liquid put in the glass. So variation would be like some people put in this, some people put in that, some people put in that. But the larger glass had more variation with the 2.97, which is like some people put in this or this, like more variation in what they put in. But the average is going to be the center of it. So you can almost, I see in my brain like a normal distribution forming around the peaks of what people put in the glass. So with that, what are we going to test right here? Well, it's a two-sample t-test because we're asking, is the average amount put in the first glass, which is going to be the smaller glass, mean one's going to be the smaller glass, minus the average amount put in the second glass, the larger glass, is that difference equal to 0? I.e., is there no difference? That's going to be the null hypothesis. Whoops. That they are the same, that the two means are the same. And then I think they're just asking, and we always have to look to the researcher's question, is there a difference? So did it change the portion size? So this is where you pick the sign of the alternative, and the researcher's question is going to indicate, is there evidence of a difference between what people put in the glasses? So very important right there. Next, we have to find the t-statistic. So the t-statistic is a test statistic, and all test statistics for 1,000 points are going to be what is in this class right here. The way we've been using test statistics, they're going to be these right here. What? So when we think about a test statistic, it's a standardized way of talking about something. It's like if I tell you your z-score is 3, you'd say, oh, cool, because you know you're 3 standard deviations above the mean. If I tell you you got a z-score of 0, you're like, oh man, I got the mean. Maybe you're happy, like, hey, this is a hard class, I'm going to get the mean. Woo! All depends how you feel about stuff. So with this, we are going to do the t, and I don't think they told us the degrees of freedom this time. This is equal to y bar 1, which this is all group 1. This is group 2 right there. Group 2. And y bar 1 minus y bar 2 over square root. And we go right here in s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2 is equal to the difference standardized, the difference between the two means. So first mean is 4.92 minus 6.28 over square root, and then 1.87 squared, do not forget to square that, over 30 plus 2.97 squared over 26. Okay, so what we got? We got 4.92 minus 6.28. Well, we'll come back to that because we got to find the standard error first a lot of times. 1.87 squared divided by 30. Oh, Sloan, you rock. Because you know I make errors. It was, did you find that error that one time? Or was it, because just a day or two ago, and then we got to square root this. I forgot to square root it one time recently. 4.92 minus 6.28. And Sloan and I got the same answer. Negative 2.014. And obviously you want to do your own work, but if you could possibly do your work with a friend and each work your problems and work them together and then practice and confirm answers, then you'll know you're doing them right. So that's really great right there. Okay, negative 2.014. We'll go back over here. Oh, this is the problem we've already done. And so here we go. Find the t-value. Negative 2.014. Check answer. Good deal. Now the p-value. So Sloan, this is interesting. 4 decimals is going to be super hard. But when I draw this out, I want you to think about what value you think about, Sloan. It's going to be really hard. It's going to have degrees of freedom like 47. But Sloan, we can take a kind of decent guess at this. This is very hard to guess this one, though. Oh, nice. Did I say about 40 degrees of freedom? So we'll show how Sloan got the degrees of freedom of 40.962, which show us the shape of the T. But Sloan, I want you to look at where we landed. And I want you to think about what value comes to mind. We landed basically at what, Sloan? Like round the number, and we landed basically at what? I did? Wow. We landed basically at what on our t-statistic? We landed basically where? Remember, we're doing the does not equal, so we shade both sides. We landed basically at 2. So what percent of the area comes to your mind right here? So what percent of area comes to your mind right here? What percent? Like when you think outside of -2 and +2, what percent? 5%. Now, since this is the T, we're going to put a little more or a little less. So since this is the T and the T is like this a little bit more, are we going to put a little bit more in the tails or a little bit less? Well, do we always, when Brian does that, these are the advanced ways of solving. We'll show you how to get the answer in a second. We're going to put a little bit more, a little bit less. The answer is a little bit more. So I'm going to guess, and we get 2 guesses here. Oh, wait, we need the 4 decimals. Okay. We didn't get it. That's all right. It's very hard to guess that right there. So let's go ahead and show how to get the answer. When doing the T, you have to first get the degrees of freedom. And Sloan already went and got the degrees of freedom for us, so let's confirm it. Oh, Sloan, is that the right answer? I should have guessed basically 5% then. So we have to put in the 2 sample sizes, and we go over here to degrees of freedom. The standard deviation 1 is that. Sample size 1 is this. Standard deviation 2 is this. Sample size 2 is this. There's the 40.96 Sloan said. Now find the p-value using the T. Go here, put your degrees of freedom in, do the outside test, grab your T statistic, put in the negative and positive version of it, and there it is right there. And there it is right there. Man, we should have just... Sloan, do you think, Sloan? No way. Remember how you said 5%? Do you remember how you said 5%? Dang. I mean, it's important that it's above, but if you just so you see, Sloan did put the correct answer in the chat, and we do have the correct answer on the screen. I was just really hoping, is it a plus or minus of like, that's super close. Think about how close you are in your guesses when you're like, about 5%. Yeah, it's about 5%. You're basically right. And that's also going to help when you see the answer to be like, okay, yeah, that makes sense. It's about 5%. So really good guess right there. Super close. It's basically 5% for all intents and purposes. But it's important to note that the actual p-value is actually what to 5%? And then we'll do Isabella's question next here. The actual p-value is actually what to 5%? So look at the p-value right here. It's what to 5%, which is the alpha. The p-value is what to 5%? It's definitely whatter than 5%. It is greater, correct. So we do not reject the null. We do not have evidence that there is a difference. So it's greater than, because the p-value is greater than, the p-value of 0.0506 is greater than the alpha level of 0.05. We do not reject the null. Thus, we do not have evidence for the alternative that there is a difference between the glasses. So that's definitely it right there. And I do like I always love guessing the p-values, because the more you get these down, the easier it is to understand why a p-value would be a certain way. So different does not equals. The difference here is about, so maybe 2 point, it's going to be negative. This, once I think that this one I will be able to guess, or I'll get close to. I don't know the T, but it's going to be in that range. Oh, man. Oh, it's positive. Because the... Wait. Did they do large minus small here? Oh, I forgot the negative. Okay. It is the negative right there. The negative 2.77. So this time I can probably get the p-value pretty close. Guessing also probably builds good... Yeah, exactly. It builds intuition. And I think we can actually guess this one. I've got more faith in guessing this one correctly because it's very small. And so it's probably going to be close to about this. So if they have a plus or minus 0.3, we just covered a range of some answers. So it's got to be a little bit bigger then. No way. It's bigger? Really? Oh my gosh, because I went to the next decimal. Okay, one more try at this. Here, we'll redo. I want to get one of the p-values by guessing it. And that would have been it. That would have been it. I'm never going to get that one by guessing it. No. Give me one more shot at this, and then we're going to do the Isabella's problem. Okay, this is going to be a t of about negative 2.3. So this is the same, equals. You're welcome, Ben. Different and does not check. The t is something like negative 2.33. Oh, it's close to that other guess. Is it positive? Oh, because we're doing... I did it right the first time. I guess they gave it to me. India, we've like this really hard test called the IITG, and we've learned guesswork a lot. Yes, exactly. This one right here has to be a p-value somewhere between 1% and 2%. The p-value has to be between 1% and 2%. And it's probably going to be closer to 2%. It's the last digit that's going to be so hard to guess. The last digit is just like really hard to guess. Sure. I should have just guessed 2%. Yeah. Oh, man, you said it. Dang it, Sloan. I think you'd been right. Sloan, no joke. Sloan, you would have got it. Sloan, you would have got it. That would have been acceptable. You would have guessed the p-value right there. What are the odds? Well, when you learn how to do what, I said about 1 to 2% between 1 and 2, apparently it was just a little bit bigger than 2%. Yeah, when you learn how to do these, you can kind of guess the p-values pretty well. And it's just hard to do that last fourth digit. If I told someone the p-value is about between 1 to 2%, I'm basically right. So it's just very hard to do these to 4 decimals because the t is different for each degrees of freedom. But if you look how close we are, I mean, I said 1.62%. My first guess was like 1.83%. I thought it was closer to 2. Yeah. So when you understand how to do these right here, you can kind of guess some p-values. Hey, Sheena, good to see you here. We're going to do one more question right here. We got some chapter 19. Thank you, Isabella. It's the pregnancy question. And let's do the pregnancy question to end. A little chill music right here. Is it on the... Here it is. Found it. Okay, so we got a lot of good practice right here. If you are watching... Let me not say this yet, because we're going to edit in the video. Stat 201, Chapter 19, quiz, most pregnancies. Okay, let's do it. Can I see my project? I give it a quick skim and tell you some advice if I see major things. So here we go. How do we write out the null for the chi-squared test of independence? If you don't know this trick, write it down. Whenever you're doing the chi-squared test of independence, you go right between your columns. So here we have age group. Yeah. Nice. Yeah. And here we have outcome of pregnancy. So when you do the chi-squared test of independence, all you do is put the word independent between them. The age somebody is, the age group someone is in, and the outcome of their pregnancy is independent. Or the age group someone is in is independent of their pregnancy outcome. And then when you do the alternative, all you do is add in the word not. That's when you do the alternative. So the age group someone is in is not independent of the outcome of their pregnancy. Remember, this is the chi-squared test of independence. So any question you see, we're going to finish this question, but if you see this question right here, the region of the country someone is in is independent of their political party. The weapon used is independent of the site of injury. The place somebody is injured is independent of the lethality of the injury. All you do is put independent between those, and that's how you write the null hypothesis for the chi-squared test of independence. So right here, they are independent is the null, and they're not independent is the alternative. Look for the independent, exactly, chi-squared test of independence. Now, here's the thing you have to know how to do. You don't have to know how to make jump output, but it's going to help. So what we're going to do is go right here, copy to clipboard. So copy to clipboard, hit Control C or Command C to copy the data. Once you've hit Control C or Command C, you can then go into Jump, and inside of Jump, go to anywhere and go to File, New, Data Table. I'll pause right there. File, New, Data Table. With File, New, Data Table, then go to Edit, Paste with column names. You don't always do that, but it's because the column names are at the top of the data set you just copied. Now you need to paste them in with the column names at the top. If you don't do that, it'll have a problem. It'll put the column names in the first rows of the data. So don't do that. We do paste without column names every once in a while. So you don't always do it. It's more common than not that you do paste with the column names. So now that we have it looking like this with a red, blue, blue, we're going to go right here and go to Tables and then Stack. Tables, Stack. With Tables and Stack, we're going to double click the blue columns right there. So we've double clicked both blue columns under Table, Stack. Now we're going to go ahead and click OK. So now we have the data right here. And it doesn't matter which one we use as the X and the Y. So we're going to go right here and go to Analyze, Analyze Fit Y by X. Let's show that again. Analyze Fit Y by X. And we're going to double click one, or click it into the X, click it into the Y, and frequency there. So there we go. Everything's good to go. Make sure it's lined up. Make sure it's red, red, blue. And now we go down here, click OK. And notice it's very flat across. So if you already know what you're looking at, you'll see that the age group is really kind of independent of the outcome of a pregnancy. And when we go down to the chi-squared test statistic, it's actually very small with a higher p-value. Now, it is important to note that you should be able to find values that are in this table. Any value in this table, you would need to know how to find, like what does the counts mean? That's the observation of individuals. What are the expecteds? That is the expected if the null is true. And the cell chi-squareds are the standardized difference. So definitely refer to lecture where we go over each part of these and how to find them. But they want the chi-squared test statistic, which the Pearson has your chi-squared test statistic and the p-value. So 1.811, extra one right there, p-value of 0.6125. And think about this, the p-value is super duper high. That's what we call super duper high. So the p-value is really high, so we're going to let the null fly. Since the p-value is high, we let the null fly, and we do not reject it. The p-value is greater than alpha. There is insufficient evidence for the alternative. And that should do it right there. Good question. And a lot of these are very similar, but know how to find values by hand, know how to find expected counts by hand, know how to find cell chi-squareds by hand. Practice this chapter, practice solving the work. It's not about just putting into jump, it's knowing how to get these values. Any value in this table right here, you should be able to get. Well, with that, I'm going to start preparing for class. But good work right there. Until next time, bye for now. Bye.